Welcome back. This is an Aleks homework video on calculating the pH of a weak base titrated with a strong acid. Okay, if you have an acid and a base and you put it in a jar, it's going to neutralize each other. Whatever you have more of is going to be left over in the water and changing the pH at the end. So if you had exactly the same amount of moles and it was a one-to-one relationship, monoprotic acid, and you had the same number of moles of acid as base, you wouldn't have any pH. It would be a 7 at the end because everything would be neutralized and you just basically have some salt water. If you have leftover acid, then that's really easy to find the pH because you just take the negative log of the hydronium content, or the H+, and that's it. If you have a strong base, that would be easy because your strong base is simply going to break apart into hydroxides anyway, and you need hydroxides to be able to find the pH. If you have a weak base, you actually have two steps. You have to think about it in two steps. You have to think about it neutralizing the acid first. Then if there's leftover base, that base would then have to react with the water to produce hydroxide. So you're thinking of it twice, okay? And you would actually need an ice table to do that in order to find out how much hydroxide you have. So if you have a weak base, that really makes it a little bit of a longer problem. So here's the first reaction. You've got some kind of a base here, dimethylamine, and it's going to react with an acid to produce the conjugate base of the acid and the conjugate acid of the base. So this is just straightforward 1-to-1-to-1-to-1 relationship. So I want to find out how much is left over. Do I have more acid left over? Do I have exactly the same amount where it cancels out? That would be the best kind of question. Or do I have more base left over? So I find out the number of moles. Okay, now they give you milliliters here, so I had to be smart enough to know that I need to put that in liters so that it'll cancel. So the number of moles times those liters will give you the amount of moles of the acid, and then the base, and then I just look which one is the bigger. So it turns out that I had more in this example, more base, and so I find out how much more base. Everything else is neutralized, and now I have leftover base of 0.05 moles of my dimethylamine. So here, once I have moles, I can do moles over liters to find molarity of the base. Now this is where it's tricky to a lot of people. Don't divide by the volume of the base you were given, because when you put the acid and the base together, that's going to create more volume than just what you were given in the base. So you have to add the total volume. So I added the 83 milliliters and the 53 milliliters. Make sure you convert it into liters first, then divide it. So I got an unreacted base of 0.41 molar. Okay, so imagine there was no acid and you just put 0.41 molar of a base in some water. What is the pH? That's essentially the question. Okay, now it is going to react with the water to make a conjugate acid. All right, so I did the very same thing. Now that acid is the same amount of moles as the original acid was. So the iodic acid that they added at the beginning, the conjugate acid made is going to be that same number of moles. So what we figured out in moles before is going to be the same. And remember, do the total volume just like we did a second ago. And now I know the amount of molarity of the conjugate acid. I'm going to need both of these because they give me the pKb. That means I'm going to have to do an equation, acid dissociation or a base dissociation equation. So I found them both because I'm sure I'm going to need them. Okay, so that means I've got an unreacted base in water. So it's going to react with the water, and here's the equation for reacting with water. Water plus that weak base is going to react to form hydroxide plus the conjugate acid. Now, I simply wrote the base dissociation equation, K sub B equation, But then I looked, and I've got a P K sub B. They didn't give me the K sub B. They gave me the P K sub B, which is rotten. So I have to remember that I can convert that, and I'll do that in a second. So the K sub B is equal to 10 to the negative Pk sub B. And they gave me the Pk sub B, so I had to raise it to the 10 to that power. And I got 5.37 times 10 to the negative 4. That is going to be equal to my K sub B. And so I put that in my equation, and then I put my molarities that I just found. Now I have to do an ice table, and so my initial, this was after I got rid of all the acid. My residual base was 0.47 molar. I found out the conjugate acid that I produced, what it was starting was 0.132 molar, and then this is my ice table. Now you see I'm trying to find X because X is my hydroxide, and that's what I'm going to need in order to find the pH. So I found my table as I just plugged in all the numbers, and it looks terrible ugly. I would hate to do this in algebra problem, and then put it to the K sub B. Now I'm going to fudge this, okay, and you're going to want to fudge this too, because the only other way to do this is a hideous quadratic formula with x's and negative x's and plus x's, and nobody wants to do that. So I remember that this is a very weak base, and that I'm not making lots and lots of product. I'm only making a tiny bit of product, and so for that reason I can assume that the amount of product, in this case the hydroxide that I'm making, is very teeny, a teeny little bit. I bet you that it's, you know, it's 100 times less than much. So I'm just going to ignore these x's. I'm going to ignore the plus x and the minus x and just consider it 0. Okay, now remember, it needs to be at least, when you do this, it needs to be very small. It has to be like 0.0000 something, okay, like to the negative 4 or 5 or something. It needs to be very small. You can't have a very large one and it work, okay? Then you'd have to do the long way, but this is the fudge way, and I prefer it. So when I solve this, I find X is 0.0016, and that's my concentration of hydroxide. I can use that to find pH in just a second. Okay? I remember that the concentration of hydronium, H+, to hydroxide equals, the product of that equals K sub W, which is a constant. It's that 1.01 times 10 to the negative 14, and it never changes. That is always going to be the same number. So I found my hydroxide, divided into my K sub W, find my concentration of H+, and then to find pH, I just take the negative log of that. And then you want 2 decimal places here. So this is very involved, this is long, there's a lot to it. Just try to keep your focus all the way through this so you don't mess up somewhere in the middle. But I hope you do well.